Alright, so now we'll take a look at the quadratic formula. So here we have a quadratic equation. Ax squared plus bx plus c equals 0. And the solutions to this equation are x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The radicand, which is this under part right here, that radicand is called the discriminant. And the discriminant can tell you how many solutions this thing has and the nature of those solutions. Let's take a look. Now, because it's a radicand, the discriminant tells us this because the sign of the discriminant and whether or not it's a perfect square can help us in figuring out what the solutions are, what kind of solutions we have. But anyway, let's go ahead and solve this quadratic equation. We first want to put it in the standard form. Ax squared plus bx plus c equals 0. You can only get the coefficients a, b, and c when it's in standard form. So we subtract 8x and add 3 to both sides. Subtract 8x and add 3. So I get 2x squared minus 8x plus 3 is equal to 0. These cancel on this side. So I can identify a, b, and c. A is 2, b is negative 8, and c is 3. Alright, so the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. And in this case, that would equal negative b, or negative 8, plus or minus the square root of b squared, which is negative 8 squared, minus 4 times a times c. And that's all divided by 2 times a. Alright, so I like to calculate the discriminant first. The discriminant. So the discriminant, let me see, well, that's just 8. And to calculate the discriminant, let me see, we got b squared, which is 64, minus 4 times 2 times 3, still divided, well, 2 times 2, we can do that also, is just 4. Alright, and then calculating the discriminant here, let's see. We got 8 plus or minus. This is going to be 64. 4 times 2 is 8. 8 times 3 is 24. So 64 minus 24. And this is all still divided by 4. Okay, so it turns out that the discriminant is positive 40. What does that tell me? Because the discriminant is positive 40, I automatically know that this is going to have irrational number solutions because the square root of 40 is not a rational number. It is, however, a real number, so I'm still going to get a real number. I'm going to get 2 real solutions. I just have to simplify the square root of 40. Well, the square root of 40, I can factor into the square root of 4 times the square root of 10. That's still all divided by 4. And the square root of 4, hey, that's a rational number. The square root of 4 is 2. So that's 2 square roots of 10. And then I can split this up to give myself, I can factor out actually a 2 out of the numerator. Factor out a 2, I'll get 8. Oop, not 8. If you factor out a 2, you're going to have 4 plus or minus the square root of 10. And then because I factored out that 2, I can cancel it with one of the 2's in the 4. And my final answer here then is 4 plus or minus the square root of 6 over 2. There's a 2 that still remains when I cancel the 2 out of the top. So this is the final answer here. Those are the two solutions to that equation. And as you can see, because 40, the discriminant, was not a perfect square, we did get an irrational number. The square root of 6 proves that that number is irrational. All right, let's try another one. So here's another. We'll do the same thing. This one is already in standard form. So I can identify A, B, and C right away. -9 and C is 8. So I identify A, B, and C right away. Well, it's going to be, the quadratic formula says that this is -b, -9, plus or minus the square root of b squared, -9 squared, minus 4 times A, which is 3, times C, which is 8, all divided by 2 times A, which is 3. Alright, so we'll work this out. That's 9 plus or minus, and the discriminant, let's see. That's going to be -9 squared is 81, minus, and let's see what we got here. 8 times 3 is 24, and 24 times 4 is equal to 96. So we have 81 minus 96, all divided by 2 times 3, which is 6. So we have this. This is what, these are the two numbers that x will equal. We simplify the inside to get the actual discriminant to be 81 minus 96 is -15. And that tells me something about the solutions there. Obviously, because the discriminant is negative, we're taking the square root of a negative number, and we are going to have imaginary solutions. Or not imaginary, but non-real complex solutions. These are going to be non-real complex numbers. So I get 9 plus or minus, and this is going to be the square root of -1 times the square root of 15, all over 6, where the square root of -1 is just I. So this is 9 plus or minus I square roots of 15 over 6. And there's nothing else that we can do with that because there are no common factors to factor out of the numerator. So nothing cancels. And this is our final answer. Alright, last one. So this one already also in standard form. So I can identify A as being 8, B as being -10, and C as being 3. So once again, the formula says x is equal to -b plus or minus the square root of b squared, which is -10 squared, minus 4 times A times C, all divided by 2 times A, which is 2 times 8. Alright, well, let's see. So this is saying that x is equal to -b. Oops, -b. We had a replacement for -b. -b is -10. -10, which is +10. So this should then be 10 plus or minus the square root of 100, and then that's going to be minus, and let's see, that's 12 times 8, which is 96. all divided by 2 times 8, which is 16. So we get x is equal to 10 plus or minus, this is the square root of 4. 4 is a perfect square, which means that the solutions here are going to be rational numbers. I could have factored this. I didn't have to use the quadratic formula. So anytime you get a perfect square for the discriminant, that means the problem was factorable. This is 2. The square root of 4 is 2 all over 16. So I get actually two rational number answers. 10 plus 2 over 16 and 10 minus 2 over 16. One of them is 12 over 16, while the other one is 8 over 16, which reduces. 12 over 16 is 3 over 4, while 8 over 16 is 1 over 2. So those are the two solutions to that equation.